Now, in this lecture, we will find the area of the yellow circle. In the drawing, we have a semicircle. The center of the semicircle is at point O, and the center of the yellow circle is at point, let's call that point O. And also we know that PQ equals to 7 times root 2. As you have already know, the area of a circle equals to pi times r square. Okay, well, when r is the radius of the circle, so pi times r square equals to the area of a circle. So the only thing that we have to find is the area of the yellow circle, and then we will know the only thing that we have to find is the radius of the semicircle, and we will know the radius of the semicircle. Then the area will be pi times the radius that we found squared. Okay, so we only have to find the radius of the yellow circle in order to find the area of this yellow circle. Okay, so actually we will connect the two centers together, the center of the yellow circle that is at point M, and the center of the semicircle that is in point O. So we will connect them together. And then we will also connect point M and P together. And actually the line segment MO is defined as the radius of the yellow circle. I will call it R, and the reason that MO is the radius of the yellow circle is because the MO starts from point M, that is the center of the yellow circle, and ends at point O, that is a point on the circle. O is a point that is on the yellow circle. So this is the definition of the radius of any circle. Any line, any straight line that starts from the center of the circle and ends at a point on the circle is defined as a radius. So MO is the radius of the circle, and also MP will be the radius of the circle for the same reason. And actually we have a rule that states that if two circles touch each other, I will call it rule number 1. So the rule states that if two circles touch each other, then their point of contact lies on the straight line that connects their centers. I will read rule number 1 again. So rule number 1 states that if two circles touch each other, then their point of contact lies on the straight line that connects their centers. So actually here we have those two circles touch each other at point P, and the segment MO connects their centers, because M is the center of the yellow circle and O is the center of the semicircle. So actually rule number 1 states that if two circles touch each other, then their point of contact, that is to say point P, lies on the straight line. P lies on the straight line that connects their centers. MO connects the centers of the circles. So PMO is on a straight line. That is exactly what rule number 1 states. If two circles touch each other, then their point of contact, that is to say point P is their point of contact, this point of contact lies on the straight line that connects their centers. So this point lies on straight line that connects their centers. So segment MO connects their center together, and P lies on the straight line of MO. That is exactly what the rule number 1 says, that their point of contact lies on the straight line that connects their centers. That line, the line that connects their centers, is MO. So the rule number 1 states that point P lies on the same straight line that connects their centers together. Again, MO is the line segment that connect their centers together. And according to rule number 1, P, the point of contact lies on the same line as MO. So PMO is a straight line. Okay? According to rule number 1, PMO is a straight line because the point of contact lies on the same straight line as MO. Okay, so PMO is a straight line. And for that reason, actually, PO is also can be defined as the diameter of the yellow circle. Okay, so PO will be defined as the diameter of the yellow circle. Okay, so and PMO is a straight line. For that reason, we can define PO as the radius of the semicircle. I will call it capital R, because of the fact that line PO exits from the center of the semicircle and ends at a point that is on the semicircle. We will define line PO or OP is the same as the radius of the semicircle. Okay, so here we have a relationship between the big radius of the semicircle and the small radius of the yellow circle. We can say that capital R equals to 2 times R. So you can see here capital R equals to 2 times R. And for the same reason, we can say also that OQ is the radius of the semicircle, because of the fact that OQ is a line segment that exits from the center of the circle and ends on a point Q that is a point on the semicircle. For that reason, OQ is the radius of the semicircle. So actually, I will draw again the triangle POQ. Before I draw triangle POQ, we actually have rule number 2 that states that in any circle a radius and the tangent to that radius are perpendicular to each other. Actually, QO is tangent to the yellow circle at point O, and MO is the radius of the yellow circle. So here we have a radius and a tangent to that radius. So according to rule number 2, I will write it down. So rule number 2 states that in any circle a radius and the tangent to that radius are perpendicular to each other. I will read it again. So rule number 2 states that in any circle a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, let's call it r, and the tangent to that radius, let's call it t, then the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and also this angle is 90 degrees. So we can implement now rule number 2 in our circle, because we have here radius, that is to say small r is the radius of the yellow circle, MO is the radius of the yellow circle, and it is also defined as small r, and we have the tangent to that radius. QO is actually tangent to radius MO. So according to rule number 2, in any circle a radius and the tangent to that radius are perpendicular to each other. That is to say, this angle or angle POQ will be equal to 90 degrees, and also angle PO here, this angle also equals to 90 degrees. So again, in any circle a radius, MO is the radius of the yellow circle, and the tangent to that radius, QO is the tangent to the yellow circle and also tangent to the radius MO. So in any circle a radius and the tangent to that radius are perpendicular to each other. That is to say, R is perpendicular to OQ. That is to say, this angle equals to 90 degrees and also this angle equals to 90 degrees. So now I will draw again the right triangle POQ. Okay? This point will be point P, this point will be point Q, and this point will be point O. You can see POQ, and this is exactly the right triangle POQ. As you can see here, side PQ of the right triangle equals to 7.7 times root 2. And this angle POQ equals to 90 degrees. So you can see here, angle POQ equals to 90 degrees. And PO is defined as capital R, and also OQ is defined as capital R. So now I will apply the Pythagorean theorem that states that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So the square of the hypotenuse, that is to say 7 root 2 square, is equal to the sum of the squares of the perpendiculars. So it is r square plus r square. Okay? Again, according to the Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. The square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So 7 root 2 square equals to r square plus r square. Okay? And r square plus r square is 2 times r square. That equals to 7 root 2 square. Okay? 2 times r square equals to 49 times 2. Okay? Here 2 times r square equals to 7 times root 2 square. And 7 times root 2 square is equals to 49. Root 2 square equals to 2. Now we can divide both sides of the equation by 2, or we can divide the equation by 2. We will get that r square equals to 49. Okay, because 2r square divided by 2 equals to r square, and 49 times 2 divided by 2 equals to 49. And the root of 49 is actually 7. We will not consider the negative answer, because the root of r square is also equals to negative 7, but because we are talking about the side of the triangle, it cannot be a negative number, so only r that equals to 7 can be the answer. So the radius of the semicircle equals to r. So the radius of the semicircle equals to r, but we already found that the radius of the semicircle equals to 2 times the radius of the yellow circle. So the radius of the small yellow circle is equal to r over 2, and r equals to 7, so it is r or instead of r I will write 7 over 2. R equals to 7 over 2, and 7 over 2 equals to 3.5 units. So the radius of the yellow circle is equal to 3.5 units, and the area of any circle equals to pi times r squared. So the area of this small yellow circle is equal to pi times r. R is 3.5 square equals to, the area equals to pi times 12.25, and the area equals to 38.48 units. I will verify that I'm not mistaken. Okay, it's correct. So the area of the semicircle is equals to 38.48 units. This is the area of the yellow circle. So that is the answer to the question. Now I will summarize the lecture. We actually wanted to find out the area of the yellow circle, and in order to find the area of the yellow circle, we have to find the radius of the yellow circle. After we know the radius of the yellow circle, we have the formula for the area of any circle is equals to pi times r squared. So we will put it on this formula, and we will find the area of the yellow circle. So in order to find the area of the yellow circle, we connected the centers of those two circles. We know we defined the center of the yellow circle as M, and the center of the semicircle is given us as O. So we connected between those two centers, and actually we have a theorem that states that if two circles touch each other, then if two circles touch each other internally or externally, okay, I will add here internally or externally, okay, if two circles touch each other internally or externally, then their point of contact lies on the straight line that connects their centers. So actually the yellow circle touches the semicircle at point P. So according to rule number 1, the point of contact, that is to say point P, lies on the straight line that connects their centers. So point P lies on the same line as the line segment MO that actually connects their centers together. The line segment MO connects the centers of those two circles, and according to rule number 1, point P lies on the same line of the line segments. That is to say, line PMO is a straight line. That is rule number 1. Because the point of contact P lies on the same line of the straight line that connects their centers together. So actually line PMO is a straight line. That is the meaning of the rule number 1. For that reason, OP is the diameter of the yellow circle, and so we wrote that actually OP is the diameter of the yellow circle, and also OP is the radius of the semicircle, because it starts from the center of the semicircle and ends at point P, that is a point that is on the semicircle. P is the point on the semicircle. So any line that exits from the center of the semicircle and ends at any point on the semicircle, it is defined as the radius of the semicircle. For that reason, OP is the radius of the semicircle also. So actually we have here OP equals to capital R, that is the radius of the semicircle, and also according to definition of a radius, also OQ is the radius of the semicircle, because it starts from the center of the semicircle and ends at a point on the semicircle. So OP is also defined as the radius of the semicircle, and we know that side PQ equals to 7 times root 2, and we have rule number 2 that states that in any circle a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, let's call it R, and the tangent to that radius, then they are perpendicular to each other. That is to say, this angle is 90 degrees and this angle is also equals to 90 degrees. So we can implement this rule number 2 in our circle, because we have here MO, that is the radius of the yellow circle. Why? Because it exits from the center of the yellow circle and ends at point O, that is a point on the yellow circle. Because of this, it is defined as the radius of the yellow circle, and we called it small r. So we have a radius of the yellow circle and we have tangent to the radius, and it is also tangent to the circle. It is also tangent to the radius. For that reason, a radius and the tangent to that radius are perpendicular to each other. That is to say, angle POQ equals to 90 degrees, and also angle PO, whatever it is, let's call it E, angle POE also will be equal to 90 degrees. But what is important is that angle POQ equals to 90 degrees. So we have here a right triangle, because this angle equals to 90 degrees. So I draw again the right triangle POQ, and according to the Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So 7 root 2 square is equal to the sum of the squares of the perpendiculars. That is to say, r square plus r square are equal to the 7 times 2 square. That is the Pythagorean theorem. And actually we got that 2 times r square is equal to 94 times 2. And then we divided the equation to 2. And then we got that r square is equal to 94. And for that reason, r equals to 7. Capital R equals to 7 units. But we have already found that capital R is equal to 2 times small r. For that reason, if capital R equals to 7, then small r will be equal to 3.5 units. Okay, so we know that the radius of the yellow small circle is equals to 3.5 units. And according to the formula for the area of the circle, the area of any circle is equals to pi times r squared. We know that r is equal to 3.5 units. So actually the area of the yellow circle will be equal to pi times 3.5 square, because r equals to 3.5. And 3.5 square is equals to 12.25, and pi times 12.25 is equal to 30.48 units. So the area of the yellow circle is equal to 38.48 units. Okay, thank you very much.